In transcription, a gene of DNA is copied into a messenger RNA molecule. In transcription, the entire DNA molecule is not going to be transcribed, only the gene. Just one gene will be transcribed. So you might be asking, how does the cell know where the gene starts? This is marked by a special DNA sequence that is in front of the gene called the promoter. I've drawn the promoter in orange and the gene in pink. So this is the promoter right here, and that's the gene. Promoter and gene. So what will happen is that the enzyme that will perform transcription will first bind to the promoter, which allows them to recognize where the gene is starting. The boxes are put in one of the strands of DNA, and that's because only one strand will be transcribed. It could be the bottom or top strand, and here I chose to do the bottom, but it could be either top or bottom. So the enzyme that is going to form transcription is RNA polymerase, and that is step 1, where RNA polymerase opens the DNA, and this is the DNA right here, and these are the base pairs. This right here is also this part right here, the gene part and the base pairs. So in this part, we can see the DNA that has been opened up. So this is the beginning of DNA code that will transcribe into messenger RNA, which is step 2 right here, where RNA polymerase adds RNA nucleotides, building mRNA. So mRNA is right here in red. So RNA polymerase has built this new messenger RNA, and you start at the 5' and add on to the 3' end, just like in DNA polymerase. However, in RNA polymerase, it doesn't require a primer, so we could just start and extend. So once it reaches the end of the gene, termination will take place, and that is step 3. Termination occurs at the end of the gene. mRNA is released. So this is where one of the major differences between prokaryotic and eukaryotic species differ in transcription. So in prokaryotes, translation begins immediately. mRNA will already start to be translated as transcription is occurring. So ribosomes can jump onto the mRNA as it is coming off of the DNA, hence begin translation. And this is because there is no nucleus. However, in eukaryotes, it is a little bit more complicated because transcription is taking place in the nucleus, and the mRNA has to leave the nucleus in order for translation to take place in the cytoplasm. And in eukaryotes, this mRNA is not yet ready for translation. And in eukaryotes, we have introns and exons, but the most important things are exons, because introns they don't contain any code for the final protein, so they have to be removed. And the process to remove introns is called splicing. So we remove the introns and we stitch the exons together. In addition, eukaryotes also have a 5 prime cap and a 3 prime poly A tail that is added to the ends of the mRNA, which improves stability to be used again and again. So right here we have the poly A tails, and right here we have the 5 prime cap. So another difference between bacteria and eukaryotes is that bacteria could be monocistronic or polycistronic, while eukaryote can only be monocistronic. So polycistronic means that the mRNA can encode for many polypeptides, while in monocistronic, one mRNA encodes for one protein and one polypeptide. So that's what is shown in the figure here. This mRNA encodes for 4 different polypeptides, and in this one right here, it could only encode 1. And then the other difference is that eukaryotes have the 5 prime cap, the 3 prime poly A tail, and splicing.